All right, so let's now answer B. It says, if the dog follows the shortest Hamiltonian path, name a bush at which the dog could start and a bush at which the dog could finish. Remember, a Hamiltonian path, if you haven't memorized the fact that a Hamiltonian path means that you want to hit each vertex without repeating any of the edges, if you haven't memorized that, you need to know where in your notes to find that. So for instance, I look at my notes, I look at my bound reference, I know it's on this page. Hamiltonian path includes every vertex exactly once, starts at different vertices, no repeated edges, do not have to use every edge. You need to know that definition. If you do not know it in the exam, if you don't have it memorized, you need to know where to find it in your bound. So that's the first thing. Okay, the next thing is making sure that when you read the question, that you are highlighting those key terms. So it doesn't just want any Hamiltonian path, it wants the shortest Hamiltonian path. Now it says, name a bush at which the dog could start, name a bush at which the dog could start and a bush at which the dog could finish. Now there's actually multiple different answers to this, so let's kind of go through it. This is also another important moment where, whenever I'm doing anything to a graph in a test or an exam, I want to make sure that I'm doing it with pencil so I can just kind of rub this out. I don't want to do it too hard with the pencil because I know that I want to come back to this now and look at it fresh. I want to figure out the shortest Hamiltonian path. So looking at all the options here, what I'm kind of thinking of, all right, can I get rid of my biggest numbers here? My biggest numbers are 60 and 50. If I can get rid of both of those, that would be fantastic. And this is where I would just begin by trial and error here. All right, I could go up here, here, here. Now, I have to include this 50. There's no way around it. If I want to hit every vertex, I have to go through that 50 here because, I don't want to go through there and I can't just randomly start here, which means I need to go through that 50. It also means that eventually I need to get to here. I'm going to have to go through there, and then all the way through to there. That's the only way for me to do it. So that means the things that I end up knocking off are the 60 and the 25. So here I started at C and I'm going to end at D, and I'm going to end up getting rid of the 60 and the 25. So that means I've reduced it by 85. Can I reduce it by more? It's also important here before I move on that vice versa. Like I could have gone the opposite way around, couldn't I? I could have, started at D and gone that way. That's also exactly the same. So just keep that in mind as well. But the aim of the game now is, can I find a bigger number than 85 that I can remove? All right. Maybe instead of getting rid of 60, we try to get rid of the next biggest number, which is 50 here. So if I start here and I go around, 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 now I want to go through the smallest numbers. I can get rid of, now, me going through 25 and 45 is better than me going through, for instance, 45 and 35, right? Because 35 and 45 is bigger than 25 and 45. So that's a better move for me to do there. Now, if I do that, I get 35 and 50. Okay, well, that means I started at G and I ended at H, G to H. That means I'm getting rid of 50 and 35. Ooh, look, 85 again. All right, the next number that I could try to get rid of. So I did 60 because that was my biggest. I got rid of 50 because that was my biggest. The next biggest is 45. If I got rid of 45 here, how could I do that? Well, if I got rid of 45, where will I start? Well, it doesn't matter. I could start either F or H here. Let's start at the F. And I don't want to go through 45, so I'm going to go around this way. I'm going to go through around that way, and that way, and that way. Now here, I would have to go up 35. Now this is where I realized that if I had actually begun at the H, here, I could have done this. I could have gone 35, then I could have gone to like 25, then gone around, and then stopped there, and I end up taking off the 40 and the 45. So that means going from starting at H and ending at D is going to leave me with 45 and 40, which is 85 again. So hopefully you can see that the biggest number that I can kind of get rid of here is that. You might be thinking, all right, can I pair two numbers that I could get rid of? For instance, is there any way for me not to go through 35 and 45? That's not possible. Because if I want to get to H, I need to go through one of these lines. So what we did here, kind of my thinking process, was I said, all right, I need to get the shortest. So let's try to get rid of the biggest pathways. Those were 60. And if we got rid of the 60, you ended up taking off all the 60 and the 25 there, which ended up reducing it by 85. Then I said, all right, what if I got rid of the 50? If I got rid of the 50 here, I ended up taking off the 50 and the 35. So that ended up with 85. And then I said, all right, my next biggest is the 45. And if I ended up doing that, I ended up getting rid of the 45 and the 40. I ended up taking away 85. Now, either of these answers would have been fine, C, D, G, H, H, D, and the order of it also doesn't matter. So that's what you're going to think of there. So that means when I come here, start and finish, I could say, C to D or D to C. If we now look at the examiner's report, it says one of start at C, finish at D or vice versa, D to H, vice versa, G to H, vice versa. So that's that question there. Hopefully the way that I've kind of thought it through makes sense to you. And yeah, hopefully this hasn't seemed too daunting.